All right, so Chapter 5, Day 3 is all about factoring using GCF. We practiced finding the GCF on Monday. Remember, GCF stands for greatest common factor, so it's the largest factor that two numbers or three numbers have in common. And remember, we talked about the word factor. Factoring means to rewrite as a multiplication problem. So we're going to rewrite as a multiplication problem using the GCF. Here are the steps to doing that. I'll give you a minute to write them down. And then we'll talk about it. All right, so today you'll be looking at polynomials, and the first thing you want to do is find the GCF. So you'll have a series of terms, maybe it's 2 terms, maybe it's 3 terms, maybe it's 4 terms. You find what they all have in common. What's the greatest common factor of the terms? You divide each term by that greatest common factor, and you write your answer like this. The greatest common factor is in the front, and then in parentheses, it's what you have left over. Okay? What are your questions? All right, here's our first example. All right, so the first thing you want to do is find the GCF. You can find the GCF by doing a factor tree. Or a lot of people, like for this one, can just look at it and see that it's going to be 5. So depending on how easy or hard the numbers are, we might do some factor trees off to the side. This one, I don't really think it's necessary, right? They're both divisible by 5. Do you guys see that? 25 and 15, the coefficients are both divisible by 5. The first one has 4 a's being multiplied. The second one has 2 a's being multiplied. Remember, we always go with the common bases. You go with the lowest exponent. So the GCF here is 5a squared. From there, we are going to go back and divide each term by that GCF. Now, this is what we practiced yesterday. What is 25a to the 4th divided by 5a squared? 5a squared. And then in the back, 15a squared divided by 5a squared is 3. So you write the GCF in the front, and then in parentheses, you write what you have left over. Remember, to factor just means to rewrite as a multiplication problem. Yes, sir.
So basically it's the GCF multiplied by the answers of the division from the terms.
Yeah, and a real quick way to check it is to just distribute. What is 5a squared times 5a squared? 25a to the 4th. What is 25a squared times 3? Sorry, what's 5a squared times 3? 15a squared. So do you see if I multiply this out, I end up with what I started with? That's because multiplication and division undo each other. So we're starting with an expression. We're rewriting it as a multiplication problem. Multiply it back out, and you can end up right where you started if you want to check your work. Don't actually do that on your paper. You'll just end up going in circles all day. That's your answer. 5a squared times the quantity 5a squared plus 3. Any questions? All right, here's the next one. Does anyone want to see the factor tree on this one? Okay, let's do the tree first then. So 8 is 2 and 4, and then 2 and 2. So that would be 2 to the 3rd x squared. Everybody with me? All right, go ahead and do it back here as well. That'd be 4 and 6, 2 and 2, 2 and 3. So this one is 2 to the third times 3 x to the third. So what is the GCF? What is it? 2 to the third. Well, what's 2 to the third? 8 x squared. So the GCF is 8x squared. Now, I'm going to go back and divide each of those terms by that GCF. And for my answer, I'm going to start with the GCF. So start with what you're dividing everything by. And then in parentheses, write what you have left over. What is 8x squared divided by 8x squared? 1. Minus, what is 24x to the third divided by 8x squared? 3x. This is my answer. Don't forget the GCF in front. That's one of the biggest mistakes I see here, is either people aren't dividing by the actual GCF, they're dividing by just a common factor, not the biggest common factor, or they forget to write it in the front. They just write the leftovers. So be aware of both of those things. Questions? Now, if you don't need to do factor trees anymore, if you saw in your head that it was 8x squared, I don't need to see the factor tree part. Okay? It just kind of depends on how much you need to get the right answer. All right. Let's see if we can come up with a GCF on our own for this one. So what's the biggest number that goes into 18 and 12? 6. Good. If you don't see that, if that's not something you're good at, do a factor tree. What about the variables? X to the third. Good. So now I'm going to go back and divide each of these by 6x to the third. What do I get in the first one? 3x to the second minus 2y. Good. X to the third divided by x to the third is just 1. So it's kind of like 2 times 1 times y. And there we are. What are your questions? Anytime I see one like this, I always ask myself if the smaller number goes into the bigger one. Does 28 go into 56? Yes. It does. So that's going to be part of our GCF. You can do a factor tree if you want. It's just going to give you 28. Or sorry, 28. 28. And then what about the variables? A, B, any C's?
No.
No. So remember, they have to have the base in common, and you go with the smallest exponent.
I thought it would be 7.
7 is a factor, but it's not the greatest common factor. So since 28 goes into 56, 28 is a factor of itself, and it's a factor of 56, so that's it. But you can do a tree if you want. If you're ever stuck, just do a tree. All right, so I'm going to go and divide each of these terms by 28AB. What's 28 divided by 28? 1. A. Good. So I'm just going to write it. Plus 2c squared. Good. This is a good one to distribute it back out and see if you end up with where you started. And you can just do that in your head. 28AB times the A would just give us an extra A, right? Which is what we needed. That takes us right back to here. And then 28ab times 2c squared, you just multiply the 28 and the 2, you get the 56. We have the a and the b, and then there's the c squared. So you're good. All right, I heard 7 from a few people, mostly in mumbles. Does anyone disagree, agree? How do we feel about 7? 7's going to work for the coefficients. I agree. Do they all have an A? No. Do they all have a B?
Well, they do. No. They do all have the A.
No, they don't.
Where's the A right here?
Right. Never mind.
Where's the B back here?
Nowhere.
Where's the C up here?
Nowhere.
So it's just going to be 7. So 4a squared b plus 3b squared c minus 5a squared c squared.
Three.
3xy. All right, so I'm going to divide by 3xy, 3xy, and 3xy. What's 6 divided by 3?
2.
What about the x's?
Split.
X squared, y. Plus. Very good. Minus 1. This is the biggest mistake I see probably in GCF. When you divide the whole term out, you need the 1 as the placeholder. Any number divided by itself is 1. If you forget to write the 1 and you distribute, this whole term would not be there. So you can't just drop off the 1. All right? Any questions? Okay. What did you say?
Negative 6xy.
Yeah, why did you include the negative?
Because both of the terms are negative.
Yes. Usually anytime the leading term is negative, we try to factor out the negative, okay? But definitely, if they're all negative, factor out the negative sign as well, okay? So I'm going to divide each of these by negative xy. Sorry, negative 6xy. That's going to change all of our signs that are left over. So what's a negative divided by a negative? Okay, so positive what? 4x plus 1. Any questions?
There's 6p squared cubed.
Very good. 6 for our coefficients. They all have a base of p, right? We have p to the third, p squared, so it's going to be p squared, the smaller exponent. And then they all have a q, but the last term just has a q to the first, so we got to go with that one. So 6p squared q. Go through and divide all 3 terms by 6p squared q. How do I start my answer?
6p squared q.
You got to start with the GCF. 6p squared q, and then, yes, 2pq. Good. In the middle, we get 3q And then in the back, all the variables are going to go away, and we are left with just 5. What are your questions? All right, here's I. 16. Does anyone agree or have any thoughts? Variables? What do you think?
I think it's going to be just 8.
Careful.
16.
Yeah, 16 actually goes into all of them. I agree that 8 is a common factor. It's not the greatest common factor. So since 16 goes into all of the other ones, it is going to be 16. How about the variables? None. Some of them have A, B's. Some of them have just A. Some have just B's. So we can't do anything with the variables. So 16 is our GCF. Divide everything by that 16. Put a 16 in the front. So your variables are going to stay the same, but the coefficients are going to change. So we're left with 3, -1, and -2. And then just keep the variables the same. All right. Yikes. Yeah, we do these the same way. Obviously, 1/7 goes into all of those, right? Anything over 7, 1/7 is going to go into. So we are going to divide out a 1/7, and then for our variables, what would we have? X and Y. Wouldn't you have to multiply them all by 7? If this was an equation where it was like equal to something, we could multiply everything by 7 to get rid of the fractions. But there is no equal sign, so we can't really do that trick on this one. When it's an equation, two things are equal, multiplying both sides by 7 keeps it balanced. If we multiply everything by 7 here, it's not balanced and it changes the expression. So in an equation, yes, but in this situation, no. So we are going to divide out that 1/7, and then they all have an X and they all have a Y. This is one where it's almost easier to think of like, what would you multiply this by? Like, what would you multiply 1/7 by to make this? 2, right? So you're going to be left with a 2 up there. What would you multiply this 1/7 by to make this? It'd be -1. What would you multiply 1/7 by to make this? And it would be 3. So dividing fractions is kind of tricky. I think it's easier to almost work backwards on this one. Or you can kind of visualize it like you're pulling the 7 out to the front. And you're left with the 2, the -1, and the 3. Don't forget to write that 1/7 X, Y up front. What?
So is it kind of like multiplying by 7?
It's undoing multiplying by 7. So like, what would you multiply by 1/7 to get that? But yeah, you're right. I mean, dividing by 1/7 is the same thing as multiplying by 7. So yes. Questions? All right, here's K. Now, 18 does go into 36, but it does not go into 42.
Just be 6.
Right, but 6 does. Very good. So it'll be 6, just X. Yeah, careful. The X is kind of like hidden behind the, usually though they'd be in the other order. So just be careful. It's right there. But then this guy doesn't have a Y. So just 6X. And again, if you ever get stuck, do the factor trees. The factor trees are there for you. That's why we spent a whole day yesterday using them. They're a great tool. Just, you know, when 25 of us are looking at the same problem, one of us can usually come up with it, you know, like that. But on your own, you might not be able to do it that quickly. So, don't forget to write the GCF up front. What do we have left in the first term?
6x to the third y.
Very good. 6x to the third y minus, careful, 3y to the third, right? And then plus what in the back? 7x squared. Good. Aren't these fun?
Simple.
12 is too many? Sorry. Your wish is my command. We're done. I don't know where L went. I don't know. Boom. It's like Dakota wished it, and there it was. All right, what did we learn today?
Factoring using GCF.
Factoring using GCF. All right, you finish the summary. I'll hand out your homework.